Before I let you loose on the other question there, I think we need to talk about how you can do this graphically. Graphically up here was just using this calc feature on the calculator, this value one. It's going to be a similar thing here, but there's a little trick because of the lack of sophistication of that technology, that calculator, 20-year-old technology in a nice shiny box. How can you do this graphically on that calculator? We still have our function on there, wherever it is. Okay, we still have this function showing here. I'm waiting for it to be 3,000. I could sit here and just do this until I get there. But again, I'm not going to get the kind of the nice number. You could get an approximate number. This value function gives you a y value if you put in the x value. But there's nothing here that's the reverse of that. We want to put in a y value and get an x value. The only way you can get around that on here is to graph a second function. If you graph, if you make y2 equal to the number you want, 3,000, then you'll see what you can do. So I'm going to go back here. I'm actually going to have to make the window a bit bigger because it doesn't even look, 3,000 is right here. It doesn't even look like I'm up to that point yet. So I'm going to change the window. I'm going up high enough this way, but I haven't gone long enough. We already know the answer is, what was the answer? 14 something. So we'll go to 20 just to make sure we see it. Change the scale there maybe. To get it to do the reverse here and give you an x value from a y value you put in, the only way you could put it in is put the y value in as another function. It graphs the exponential function, and then what's it going to graph after that? How is that y equals 1,500 going to look? Yeah, just like that, right? That's where it reaches that, right? This is just saying that is going to reach 3,000 right there. Then you can use this calculate menu to find the intersection, which I'm pretty sure you've done before. It asks you first curve, second curve. It's kind of a stupid calculator. It doesn't, well, that's how technology has to be, right? It doesn't realize, it's not a human being. It doesn't realize there's only two things there. It has to ask you, which two things are you talking about? Well, those two right in front of you, that's the first one. That's the second one. It also wants a guess in case there's more than one crossing point. Can't tell that there's only one, so you got to tell it. You can guess anywhere if there's only one. It finds that intersection. That's the same value as you had before. Check things graphically. When you find an answer algebraically, check it graphically. You'll catch your mistake here because this is a completely different method. If you make a mistake anywhere in your procedure of the algebraic stuff you're doing, you'll catch it here because you get a different answer and you'll be able to see which one makes sense and so on. Okay? Okay, then you need to use intersect. Okay, under the calc menu. If you explain it to yourself in your notes however you feel it's going to be useful. I'm going to help you remember. Let's put that in there. And it moved everything else. It's going to look different, the second problem here. But I want you to try and go through and do this. Remember that this is decreasing at a rate of 3%. Think about what the Pringles can would look like. I can't show this in the video, and we didn't even paused it before, but what would the Pringles can look like if it said, now, 25% less? What would the can look like? Here's the red can. What would happen? Down the corner. It'd be down, right? You're going to be less than 100%. For something that's decaying, the number you're using is less than, right? You start, maybe I'll draw the Pringles can here. Here's your original amount, right? When it's exponential growth, got to make it match. There's yellow. I'll do that because you can't see it. Whoops. That's very strange. It's going the opposite way as my pen's going. But you can't tell then. Let's try again. Okay, there's the extra part. The Pringles can that says this is the original 100%. and this is the new 25%. If it was decreased by a certain percentage, right? Think about how that's going to be affected by this thing here. How is that going to change things if I have that? If it's less now, this is now going to be, can't get at that. This is going to be down here now, right? This is going to be lower. That's not really, I didn't do it to scale, did I? This is just way too many things here. Come on. Okay, well, you get the idea here. Let's draw that again. Let's make it look a little more reasonable size. There it is. Now, it's not 25% more. It's going to be, if it was the Pringles can, now 25% less. What percent do we have? If you've gone up to 100% and then down 25%, what percent do you have left? 75%. If you're decreasing at 3% per year, you have to think about in your model function, you're still gonna write it as some starting number times some kind of rate to the power of whatever the time is. But you have to think about how the rate affects what's happening with the graph. Go through and work on that. Check with other people. Confirm things with a graph. Solve it algebraically. I think you'll gain some good understanding by doing that. All right?